I wanted to go over a couple of these diagrams as a refresher before you do your own from the notes. You're going to notice these ones right here are not in your notes. So just a reminder that what this diagram up here says, JP, is x plus 2 times x plus 3 equals x squared plus 5x plus 6. That's what that diagram says. We've seen these diagrams before. You might not be seeing that 5x. It's right there. Okay? So, if we have our binomial x minus 6 times x minus 2, you guys are going to help me fill out the diagram. X times x? X squared. X times negative 6? Negative 6x. Negative 2 times x? And then negative 2 times negative 6? 12. And we've done this before, right? X squared equals negative. X squared minus 8x plus 12 is equivalent to the factor form. And the reason we want the ability to have both is this. My zeros are negative 2, 0, and negative 3, 0. And my y-intercept is 0, 6. Just looking at it, right? What we really need to pay attention to is what number from the function is going where. So we have words for this. What is this term called?
X squared. That term.
It is x squared, but what's that? The quadratic term. It's always the quadratic term because it's x to the second power. What are these terms called? Linear, because they're to the first power. And what's this term called?
Constant.
The constant, because it is that, right? It just is that. So focus on the quadratic, the linear, and the constant as you go through making your own for the examples that are in your notes. Let's set up these diagrams. The first one, it could look a little different than this, but I got an x squared and a 3x. So I proved it. Okay? The second one, some people did a 0. Anybody in here do a 0? They put like a 0 there. It's fine, but you didn't have to. So there's my x squared and my negative 6x. Now here's where we're going to really look for kind of like an emerging pattern. When I've got my x and 2, my x and 4, I've got an x squared, 2x, 4x, and 8. When I have my x, 4, x, and 10, I get my, whoa, I did a weird line there. X squared, 10x, 40, and 4x. This x is supposed to be right there. 2 more. X plus, oh, that's a negative 5. X negative 5, x and negative 1. X squared, negative 5x, negative x, and 5. Home stretch. I got a negative 1. I got a negative 7. X squared, negative x, negative 7x, and 7. Here's what I want you to bring your attention to, right here. There is a relationship between our linears and our constant. There's a relationship between our linears and our constant. And I want you to find that and write it down under number 2 in your notes. So who'd like to tell me what they notice? There's a pattern or something that happens to be true every time. What do you notice between the linears and the constant? Meredith.
If you take like the constant out of the linear numbers and multiply them, then you get the y-intercept.
So the coefficient of the linears multiplied to equal the constant. I'm just saying. Another thing I want to notice is the sum of the linears, right, equal the linear in the trinomial. Right? When we combine like terms, here's a 14, there's a 14. Let's check it out. I multiply the coefficients, 10 times 4, I get the constant. Ryan.
Why can't I just do this? You have like you have the equation, you put the x's there, and you just put the numbers there and there, and then
Yeah. So just to reiterate, we established that the linear term is the sum of these two portions, and the constant term is the product of the coefficients. So that happens every time. So we're going to use this like little pattern of discovery that we have and extend it to go back and forth between factored form and standard form. Again, standard form is really good for finding the y-intercepts, right? I'm circling them. Boom, 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 boom. Factored form is really good for finding the x-intercepts, right? 5, 1, 1, 7, just by looking. So if we have both forms, we can seriously look and get x-intercepts and y-intercept, just looking, right? That's why we want this flexibility. So you're going to practice on that little table, next page, you're going to practice going back and forth a little bit here. Remember that the linear has to add, the constant is the product that works. The first ones, I think you're probably golden with distributing, x squared and 7x. These have a common factor of x. So I'm going to roll through these because I think you've got it. Common factor of x, x squared, 8x, 12. Right here, notice, sum of 8, product of 12, like we were talking. So when we look at this x squared plus 13x plus 12, I'm actually going to rewrite that bigger. X squared plus 13x plus 12. What we're noticing is we can't just factor out a factor of x here, right? So how am I going to get my x squared? What has to happen, Sean?
X times X.
X times x. So I'm going right here. Boom. X times x. We saw it every time with our diagrams, okay? Now, I need, remember, the linear is the sum of two numbers. So the linear is the sum of two numbers. And the constant is the product of two numbers, just like we saw in diagrams. So what two numbers would give me a product of 12, but a sum of 13, Troy?
12 and 1.
12 and 1. So there it is, x plus 12, x plus 1. And here again, here's why we need to learn this. Our y-intercept is 12. Our x-intercepts are negative 12 and negative 1, just looking at it. All right? I'm going to do 2 more, and then I'm going to give you a shot to go fix things. So x minus 6 times x minus 2. I've got x squared. The sum, negative 8x. The product, 12. Okay, and we're going to do one more. X squared minus 7x plus 12. I know that I need an x times x to get my x squared. I know that it needs to multiply to be 12, but add to be negative 7. So here's the next thing I know. How do I multiply to be positive? What are the only two ways?
Negative times negative, positive times.
Yeah, positive times positive, negative times negative. But if my sum is negative, that means it has to be negative times negative.
That's why you always hear it.
So what multiplies to be 12, but adds to be negative 7? Kai? Negative 3 and negative 4. So x minus 3, x minus 4 is going to go right there. Again, we want this because check it out. My x-intercepts are 3, 0, 4, 0. My y-intercept is 0, 12. All three things just at a glance. So what I'm going to do now is give you a couple minutes to go back through the rest of this and make adjustments if you need to. So as we continue to look through these, I'm a fan because they feel a little bit like a puzzle to me. Who would like to hit me with the two binomials and how you know? Ryan?
X plus 3 and x plus 3.
X plus 3 and x plus 3. And how do you know that?
Because if you multiply the 3 by the x, you get 2 3x's.
Yeah. 3x and 3x is 6x.
3 times 3 to get 12.
Great. So sum product, right? All right. Next one up. We've got x squared plus 10x plus 9. Who'd like to tell me what they got and why? Sean?
X plus 1 and x plus 9.
Whoa, whoa, whoa. I got x plus 9 and x plus 1. Okay, we're good. All right.
And
Adds.
They add up to 10 and then the products.
Yeah, added 10, product of 9. So I got x plus 1, x plus 9. Next one, x squared minus 10x plus 9. So similar, but that middle term's different. Ivy.
X minus 9 and x minus 4.
It has to multiply to be positive, but add to be negative. That's how we know we need the negative negative. Again, just a reminder, we can see x-intercepts of 9 and 1 and a y-intercept of 9 by doing this. So x minus 9, x minus 1. JP, we got x squared minus 6x plus 9. What do you have?
X minus 3 squared.
X minus 3 times x minus 3. Negative 3x plus negative 3x is negative 6x. Negative 3 times negative 3 is 9. And I'll take this last one. Oh, Troy wants a shot. Okay, Troy.
Yeah,
I think it's x plus n or x plus
Yeah. The sum gives me the linear. The product gives me the constant. Cool. Same. Do you see what I mean by same concept there? It looks confusing because there's like x and m and n and cool.